All right, so what we're going to look at today is some of those problems from your packet. So the first one we're going to do is number 42. So number 42 reads, by what factor must the sound intensity be increased to raise the sound intensity level by 13 decibels? And explain why. All right, so we're trying to figure out what is the new intensity going to be if I multiply the first intensity by something. What's that x got to be so that the difference in sound intensity level, the change in beta, is going to be 13 decibels. All right, so let's start out with our equation here for the change in decibel level is 10 times the log of I2 divided by I1. But in this case, instead of I2, I'm going to be putting in x times I1. And what happens to those I1s? They cancel for me. So really, I'm just solving for this factor, this x, this coefficient of that. So I start dividing, so I have 13 divided by 10 gives me 1.3 equals the log of x, and then we just solve for x, so I get x is equal to 10 to the 1.3 power, because remember when you get rid of that log, and this is log base 10, this becomes the exponent, so it's 10 to the 1.3 power. So you go ahead, you get your calculator out, and you plug in 10 to the 1.3 power. You get 19.95, so about 20 times greater. Okay, so 20 times, we'll just write it like that. 20 times greater is the increase in the intensity just to gain 13 decibels because it's in a logarithmic scale. So 10 times greater increases at 10 decibels. To increase it 20 decibels, it's going to be 100 times greater. So to go 13, we just got to go 20 times. So you got to actually figure that out. All right, let's go ahead and set up the next problem. All right, we set it up. So here we have it. We're going to go ahead and read problem number 46, and then we're going to go through it. So number 46, the intensity due to the number of independent sound sources is the sum of the individual intensities. So if I add up all the intensities, I get the total intensity. All right, when the 4 quadruplets cry simultaneously, how many decibels greater is the sound intensity level than when it was single baby cries? Okay, so let's go ahead and figure that out. So we have 4 babies, so that means there's 4 intensities. So my total intensity here would be 4i, and my intensity here would just be I. So again, we're looking for delta beta. How much increase in the decibel level do we have? So delta beta is equal to 10 times the log of I2, which would be my 4 babies, divided by my 1 baby. And so my i's cancel out. We're going to go ahead and solve for delta beta. So all we need to do here is go ahead and plug that in our calculators. So we have 10 times the log of 4. And I get 6. So this increases it by 6 decibels. Now part B wants to know, to increase the sound intensity level again by the same number of decibels, how many more babies do you need? So we want to go up not just 6, I want to go up 12 decibels. Okay. So let's go up to 12 decibels, see how many babies we need for this. All right, so I have 12 decibels equals 10 log of some number of babies times the intensity divided by the intensity of 1 baby. Okay, so we're going to go ahead and solve for that n here. So I get rid of those i's, divide the 10 over, so I have 1.2, the log of n. To get rid of that log, remember we got to do that exponent thing, so 10 to the 1.2 will equal n. So if I go ahead and type in 10 to the 1.2, and I stored that number, so you get 16 babies. So if you want to go up double that, because it was 6 and change, but I stored that number, so you end up with 16 babies. So if you had 4, you need another dozen more babies to get up to that, go up again by the same number of decibels. Okay? All right, so let's set up the practice problem for you. Now, when we set this up, I'm going to give you a second to pause the video, and then I'll solve it, and you can replay it once you've tried it, okay? Here we go. Let's set it up. All right, let's take a look at that practice problem. If you need to pause and go through it, go ahead and pause and go through it. and come back to it. So we got that juicy conversation. You can hear it at 20 decibels at 15 meters away. How close do you got to be to hear it at 60 decibels? So go ahead and pause if you need to. Hey, you're back. All right, let's go ahead and go through this thing and see if you did it right. So we are going to start with this idea that you are at 15 meters away and it's 20 decibels, that juicy conversation you want to eavesdrop in on. You want to know how close do you have to be away in order for it to be 60 decibels. So now I'm comparing 2 decibel levels, 2 sound intensity levels. So I'm going to go ahead and use my delta beta. So I have 60 minus 20. All right, so I have 60 minus 20 equals 10 log of the higher intensity minus the lower intensity. So the intensity of power divided by 4 pi r squared when it's close, divided by the power divided by 4 pi r squared when it's far away. So this would be my 15 number here. Now you'll notice when I make that substitution for I here, what happens? Well, I got that 4 pi that cancels out. Also, what's going to be the same? Assuming that conversation maintains its same power as you get closer. They don't whisper more. Assuming it stays the same power as you get closer, we're going to assume that power is the same too, and so that will cancel out as well. And so then we're going to be left with, over here I have 40 divided by 10, so I get 4 equals the log of, and this denominator on the bottom goes to the top, so I have 15 squared divided by r squared. So my goal is to go ahead and find r here. And so I have the log, so I have 10 to the 4th equals 15 squared divided by r squared. So r is equal to the square root of 15 squared divided by 10 to the 4th. So how close do we got to get here? So the square root of 15 squared divided by 10 to the 4th power. It turns out, I forgot about, it turns out you got to get into 0.15 meters. So you got to weasel yourself into 15 centimeters away. So you're getting in there pretty close. Probably not a private conversation at that point when you join up like that. So that is the answer to the practice problem, 15 centimeters or 0.15 meters. Actually, I should note, go ahead and now you can do homework number 2. So you should be able to finish homework 1 and homework 2. Go ahead and do that.